So good afternoon to one and all. Is it audible? Screen is visible?
Yes, sir.
Okay, thank you. So yesterday we have discussed about the instrument transformers. In that one, there are two types. One is current transformer, another one is potential transformer. And we have discussed about the transformation ratio that is called primary to the secondary for both CT and PT. The phasor or magnitude of the primary phasor to the secondary phasor, that is called transformation ratio we are going to call. For the nominal ratio is also same, but it is rated primary to the rated secondary for both CT and PT. But the difference is in the turns ratio. Actually, the turns ratio N, that is number of turns of secondary winding equal to number of turns of primary winding, we are going to call it. NP equal to, sorry, NS equal to N into NB we are going to call here. So NP equal to 1 by N, NS we are going to call here. No, like that, this is for the PT primary, number of primary winding turns equal to number of secondary winding turns here. So these definitions, just for your understanding, I have considered for the basic starting only here now. After that, we have discussed what do you mean by current transformer, that is how it is going to reduce from the higher current to the lower current, what are its construction and working principle we have discussed in the last class here. It is always works as a short circuit because the emitter having very less resistance it is having here now. So while connecting and disconnecting, we are going to close this switch here now. Otherwise, the switch will be keep open while doing the measurement. We have provided this terminal into ground also for the over voltages or for any in the fault condition, and for the it should not hold this maximum voltages, and during that condition to bypass that one we have connected the ground here now. So the types, actually three types we have discussed: Wund type, bar type and toroidal type current transformers. Yesterday we have discussed. Today we are going to discuss about the derivation of this transformation ratio and phase angle error here. The transformation ratio and phase angle error derivations we are going to discuss. First, we have to know what are these parameters, what do you mean by N, what do you mean by X, and all the things we should have to know first. Okay, so what it is going to do based on this phasor diagram we have here now. So before starting the phasor diagram, first we should have to know the directions are represents, R represents what, X represents what it is going to, we are going to discuss here. So N equal to turns ratio, that is number of secondary winding turns equal to number of primary winding turns we are going to call here now. So RS equal to, that is called resistance of secondary winding we are going to call. It has primary winding as well as secondary winding. Both the windings have their resistance and reactances are there. So for the primary winding, it is, sorry, secondary winding, that is called S, it is going to represent, and primary winding it is going to represent P over there. So RS equal to resistance of the secondary winding, that is RS, it is going to represent. Reactance of the secondary winding, it is going to represent XS. It is not visible clearly, yes, I think. That is called RS we are going to call here, that is called XS we are going to call. Resistance of external burden, that is called external, we are going to use for the excitation coil and all the things, including LEDs, that is called RE we are going to call here now, external, that is called RE. And X0, that is called reactance of external burden, that is called reactance of the excitation coil, that is called XE we are going to call XE. External resistance, external reactance we are going to call. EP is nothing but here, that is called primary induced voltage in the primary winding. Whatever the EMF induces in the primary winding, that is called EP, and the EMF induced in the secondary winding, that is called ES we are going to call here. So these parameters we have to remember, this representation we have to remember first. Remember karte ka? All of you. RS means XS. Is it clear?
Yes, sir.
So the easy method to remember, easy is there actually. Resistance, we are going to consider RSS means resistance. The secondary winding, it is going to represent this one. Suffix, it is going to represent winding here. Now this E means external, E means external, P means primary, S means secondary. These many things you have to remember. If R is nothing, R is there, then resistance. X is there, then X indicate what? R, X, Z. Can anyone tell? R indicates resistance. Yes.
Reactance, impedance.
Reactance, impedance. And why? This is inverse of actually Z here. No, admittance we are going to call it. It will comes under next power system 3. It will comes over there. So now here you are going to study up to here only. R, X, Z you are going to study here only. So next we'll go for the next one, that is called. So number of turns are there in the primary and secondary winding. Both the windings, they have some number of turns over there. Yes. So the number of turns in the primary winding, it is represented by NP, and number of turns in the secondary winding, it is representing as NSL. So voltage, the output voltage at the secondary winding, that is called Vs we are going to call, and the secondary current, whatever the current flowing through the secondary winding, that is called, just a minute, someone has joined, that is called IS we are going to call here. Now IP is the primary current winding, current flowing through the primary winding. Theta is the phase angle of a transformer, phase angle, voltage angle between voltage and current here. Now this is called theta. Phi is the working flux, how much flux it is generating by giving a supply to the primary winding, how the flux linkage is there for the secondary we are going to call. And delta here, now angle between secondary induced voltage to the secondary current. Whatever the EMF induces in the secondary winding, so in this induced EMF, this voltage between, angle between voltage and current, that is, it is going to represent, that is called delta here. Now induced EMF only it is going to consider. The phase angle of the total burden, whatever the external we are using here, no, that includes the secondary winding, that is called phase angle we are going to consider, that is tan inverse of secondary winding reactance, external winding reactance, and secondary winding resistance to the plus external resistance here now. So it is the tan inverse of XS plus XE equal divided by RS plus RE here now. That is external burden we have used here now. See one more, this delta is there. This is square delta. This one phase angle of secondary load current, that is called external burden. You can consider that one XC by RE also you can consider, tan inverse of XC by RE. Just a minute, some people they are joining. 28, 35. Okay, so next I naught is the exciting current here. No, the winding we have to do the excitation. For that reason, I naught is the excitation current. IM is the magnetizing component of the exciting current here. Now, it the excitation current is the combination of IM and IE here. Now, IM plus IE equal to I naught. We are going to use equal to I naught. That is total excitation current equal to magnetizing component current, and the some loss is there, that is called IE or external or exciting current we are going to call here now. Loss of exciting current here now. So these many representations are there. You remember that one. Next we'll go for the equivalent diagram of the single phase transformer. Equivalent diagram we have considered. According to that diagram, we have drawn the, what we have drawn? We have drawn the phasor diagram here. So this is the equivalent diagram. According to that, we have drawn the phasor diagram here. See here, equivalent diagram, mainly it has primary winding and secondary winding. This one we have considered as primary winding and secondary winding. For the primary winding, we have to do the excitation. For that reason, we have taken one excitation winding, that is which is having some resistance and some coil here. Now inductive coil it has. So the total current flowing through the primary winding, that is called IP, we are going to call here. This is IP here. This is IP here. So IP, and this current IP, it will start to up to, it will flow here, it will flow here, and it will stop here now, and some current will flow here, that is exciting current, we are going to call that one. It is going to excite the coil by magnetizing, and some losses will be there over there, loss component here now. So it is going to exciting the winding here, it is going to excite here. Next, the left current, that is IP, whatever X IP minus I naught is there here. Previously IP tha, usko IP minus I naught, it will start to flow in the primary winding. So because of current flowing through here, the flux will produces, that will link with the secondary winding. Because of the primary current only, the secondary winding, the current will produces here, no? EMF will induces in the secondary winding. Yes or no? The EMF will induces in the secondary winding here now. So due to the mutual inductance method here now, EMF will induces in the secondary winding here now. So that secondary winding, the current, it will flow here, that is called IS, which will flow through the RS and RX, and the at the output side we are going to get, that is called output load, or we can add that one here. So that is called, so the voltage across this one is secondary voltage, and EMF induced voltage across this one is, that is called EMF induced here. So this is the equivalent diagram of single phase transformer. Now you consider only this much, you consider here. You consider only this much here. From this circuit, the circuit it is looks like here. One side it is IM is there, another side it is resistance is there. So two parallel paths are there, two parallel paths. Here the current I naught is flowing here now. I naught is flowing here now. Here IM is there. IM is there. Here IE is there. Okay. So by seeing this one, can you tell the formula for I naught? I naught equal to what? Can you tell the formula for I naught? I naught equal to I naught equal to what? For the parallel circuit, total current ka I equal to I1 plus I2 only we are going to call. Yes. If any parallel circuit is there, here up to here it is I naught is there. At this one, some current will flow here, some current will flow here. Again, they will join together and it is going to produce the I naught here. So can I write this one I naught equal to IM plus IE? You can write like this. Yes or no?
Yes.
Hello, I am asking two people only. Is it audible?
Yes, sir.
So I naught equal to IM plus IE, we can write like this.
Yes, sir.
Yes. Okay. So this is one current it is happened here. Next, this is IP is there here. Total current IP is there. So IP equal to what is this current here now? I naught here now. It is a combination of I naught plus because of this IP only, the EMF will induce us in the secondary winding. So the current will produce us in the secondary winding here now. So that is depends on number of turns here now. So that is product of NIS we are going to call here. IP equal to I naught plus NIS we are going to write that. This is also it is acting as a parallel path. Some IP equal to here I naught will produced by because of the IP only. Same current will flow here, and because of this one EMF will induce us here. So that number of turns and the product of the EMF induced or current induced here now equal to, that is the part of IP here now. So IP equal to I naught NIS we are going to call. Why I am taking these all the things means to draw the phasor diagram you should know from the this circuit diagram only we can, by observing the circuit diagram only we can draw the phasor diagram here. So I will start the phasor diagram by taking this is phi. That is flux phi. I am taking the reference line here. I will taking the reference line flux phi here. Okay. So next what I will do, I will not take IP directly. we will come that here IM and IR we are going to consider. IM and IR here. So IR, that is called resistance is there. IM is inductance is there. So this one, whatever the flux is there, that is inductive only. So already it is lagging here now. So this one we are going to consider as leading, and this one we are going to lagging here now. So the magnetizing current is in phase with the flux here now, because it is magnetic field only. So that one I will draw here IM here. Up to here, that is the current, I will draw the magnetizing current here. And the difference between magnetizing current and actually magnetizing current and resistance current should be 90-degree here now. That is external current. So I will draw the external current, that is external component current, that is here IE here. Here IE I have drawn, here IM I have drawn. According to formula, I naught is combination of IM plus IE here now. Here IE is there, here IM is there. So dotted line you join together here, here and here, and whatever the from the 0 point to here, so shift that one. That is we are going to get the I naught value we are going to get here. We have shown I naught here now. So that angle we are going to consider, that is called alpha degree here. The flux to the this one, that is called alpha we are going to consider. That is called alpha here. So up to here it is clear. IM, IE and I naught here. Is it clear? Yes or no? Hello. Oh, good everyone. I am asking to you people only. Is it audible? Audible like that? Anybody please reply?
Yes, sir.
Yes. Just a minute. Sorry. So what happened? Is it audible? Hello.
Yes, sir.
Okay. So I naught equal to IM plus IE we are going to consider. So according to that, first we have to draw the IM line and IE line. So here inductive is there, here resistance is there. Okay. So the angle between inductive and resistance, that is 90-degree difference should be there while drawing the phasor diagram. So always the resistance current will leads the inductance current here. So that one IE is leading IM here now. So here IE and IM we have considered here now. So according to this formula, I naught equal to IM plus IE. So the summation of IE and IM, that will give the I naught value. So for that reason we have taken here, and this is the I naught value we have drawn. Is it clear? Is it clear? This is I naught. I naught is there. Next we have to prove this IP. We have to prove here. No, already we have taken here I naught. We have taken here. No, so we have to take the dotted line here. No, so NIS is nothing but that is reverse. That is mirror copy of IS. We have to take that. First, what we have to do for that reason here the EP, that is EMF induced in the secondary, we are going to call this one as this is ES. We are going to consider here. That is mutual inductance. That is because of mutual inductance, EMF induced in the secondary winding, that is called ES. This line it indicates ES here now. So according to this, start the phasor diagram here now. So the current, it will what it is do. So that is resistive and inductive load we are adding here now. So that is current lags the voltage by some angle here now. So we have drawn this is the current delta here now, voltage and current here. Combination of resistance and inductance is there here. So we have drawn here IS is there. So IS we have drawn here. You have taken some angle, that is called IS we have drawn here. By making the difference of the angle between ES and IS, induced EMF voltage in the induced EMF and induced current here. Now angle between induced current and induced EMF, that is called delta here. Okay, next the output side, what is the secondary voltage you have to draw here now? That is called VS we have taken here now. That is VS here now. From this VS, it is depends on what? That is depends on this resistance here now. Next, it is not at stopped here now. So this IS into RS, that is always in phase with the voltage only. I have considered that one like this here now. That is called IS into RS here. Next, IS into XS, that is we should lead our 90-degree difference with this one and this one here now. So from considering this one here, I will erase all the things and you can check that one 90-degree hai kya nahi, aap check karo baad mein. So everything is only that point I will keep here now. That point I will keep here. This one. See here, from here to here, it is there 90 degree. 90-degree difference is there from here to here. Yes, this is ISRS, this is IS into XS. 90-degree difference is there or not here now? It is like this, they have drawn here now. It is 90-degree only. Rotate it. By rotating this one, it will comes like this here now. Yes. So that is 90-degree difference is there. But what we have to do, this IS current, induced current in the secondary is because of the primary only here. No? So the primary current, to identify the primary current, what we have to do, the mirror copy of this one we have to take, not mirror, to extend in the opposite side, that will call as NIS we are going to call here. N into IS here. That is called N into IS is nothing but we are going to consider that is IS by N, that is 1 by N we can write as minus, sorry, not that like that, we'll leave that part here now. So when we will send into primary side this current, we are going to draw that one. We should have to multiply the number of turns here now. That is turns ratio, you have to multiply that one. So N into IS we are going to call here. N into IS, that is called this NIS we have drawn now. NIS we have drawn. Next, here I naught is there. What is the formula? I told that one IP equal to I naught plus IP equal to I naught plus NIS. I have told like that only, na? Yes or no? So according to that, here NIS is there, here I naught is there. You join these 2 points here now. The dotted line you take it and you can find the IP here. You can find the IP over there. We have found that one over there.
नाही.
Okay. Okay. So this is the input current, that is called IP, is the combination of I naught plus NIS, that will give the input current here now. So to derive the transformation ratio and all the things, we have to modify this phasor diagram into some parameters we have to change over there. So to discuss that one, I will show another phasor diagram here. So up to here, this one we are keeping as it is only. So instead of this one secondary winding, we are going to consider in the primary only. We are going to modify here now. This one, whatever the I naught value is that here. See here, I naught we have considered here now. That one, according to this parallel here, this one here, I naught is that this line A to B. I will mark this one as A and this one as B, this one as C. See here, these two angle is same only. This one and this one. Yes. Here also alpha is there. Here also alpha is there. Can consider that one like this. Just a minute. I will consider like this. It is nothing but the angle is same only. Like a parallel paths, we are going to call this one here. Yes or no? Hello. Yes. Some people to go to the anywhere, so some parallel paths they are going to consider, but the distance will be same only. Distance will be same only. Like that, the distance of this one, whatever this I naught value, here I naught is there, that one we are going to consider as I naught here. But these all the things we have to do assumption now. Remember that one here. Assumption we are going to do. Next, what we have to do, we have to straight one line, dotted line I will take, and we will continue this NIS is there. I will continue into this straight line here now. That is called where it will intersect these 2 points. That point I am going to give as B here now. Starting point I will consider as A, and this IP point I will consider as C here. A, B, and C here now. I will form one triangle I have formed here now. So without this triangle, see here, A part, this part, and this part is extra I am taking here now. Other parts are same like a previous diagram here now. Is there any change here now? Up to here, it is no change here now. What I have done, instead of this one, I have taken here 90 degree up I have taken, and this straight line I will send here now. Like this, where it will intersect both that point, I will consider this is I will consider as A, this one I will consider as B, and this one I have considered as C here. To determine the transformation equations and to derive the equations, I have considered this one here. Is there any doubt here? Only this triangle we have considered here now. Other things other than this, there is no change at all. See here, this one only I am telling here now. This diagram, if it is not there, then the phasor diagram is same like previous one only. Yes, this is the phasor diagram we are using. Same like that only we are using. To derive the equations, we are considering these many changes we have modified here. Now you only observe, only you consider this triangle only here now. This triangle only to consider that one. Just I will rearrange that triangle. I will draw like this. Just see here now. This one is I naught. This one is I naught. Okay, where I naught is in between A and C here. This is A, this is C, this is B we are going to consider here. B we are going to consider. If it is I naught, here this is 90 degrees there. This is 90 degree. See here theta is, sorry, here delta is there, here alpha is there. So we want the angle between these two here now. This one we are going to draw here. Angle will be this one here now. So 90 minus alpha minus delta. Total angle कितना है? Total 90 है. इधर से इधर 90 है. Yes. So this one you minus it and this one you minus it, will get the exact angle for this one here. So 90 minus alpha minus delta here now. That is, this angle is 90 minus alpha minus delta here. We are going to consider like this here. Next, what we have to do, this one is I naught, then according to this adjacent and what is that one? Opposite, adjacent, hypotenuse here now. Like that, by considering this one, this is a adjacent is there. We can write this one as a I naught, this I naught into sine of, sorry, not sine, cos, na? I naught cos of who is this? He's joining now. This side, this is actually a little bit changed number. I will change that one here now. This one is A actually. AC, where it is B2. This is C here now. This is B here. So I will write now I naught. उसका पहले भी एक clarity देता हूं मैं आपको. So listen, what is the adjacent formula? Formula for adjacent angle? Cos theta equal to what? Cos theta equal to adjacent divided by hypotenuse. Yes or no? Cos theta equal to adjacent into hypotenuse. Sin theta equal to opposite by hypotenuse. Is it audible or not? कोई तो reply दे दो थोड़ा. This is completely derivative part. If you are not ready to give the reply, then you will not understand. मैंने direct लिख सकता हूँ formula. Then also for your understanding, I am telling these all the things. Directly it is how much it will time it will take to explain here. ये है बोल के बोलने के लिए. हाँ? See here, this is B we are considering, means we can write this adjacent formula I naught into cos of this 90 minus alpha minus delta here now. And for this one we can write as I naught sine of 90 minus alpha minus delta here. Minus alpha minus delta we can write here. So that is this I naught cos theta. It is nothing but AB. It is nothing but AB. We are considering here now. This is BC here now. This is BC. You can consider same thing we have written just to check it, cross verify here now. So we have BAC at 90 degree here now. B, A and C here now. This triangle we have 90 degree. We have considered 90 minus alpha minus delta here now. The angle between BAC is 90 minus delta minus alpha here. A to C, what is the value here now? A to C, anyone? एक मिनट I will erase. क्या बोल रहे?
I naught.
I naught. AC is I naught. We have written here now. AC is I naught here now. OA equal to O to A. Here O means this one here now. O to A is how much it is? N into IS here now. N into IS we have written. O to C is nothing but directly from here to here. How much is there? What is this one? IP. Yes or no? Any one person reply. Oh, this is OC equal to IP here. So now OA is over, OC is over. Now our term is we have to identify BC here now. BC. So for that reason only I told here this is the BC, that is called I naught sine 90 minus alpha minus delta. Why this is I have written directly here, but by using the adjacent opposite, that is cos theta sin theta formula, we have derived this equation here. How derived this equation here? I naught I, that is I naught sine this reactive component and active component we are going to call. For reactive component sine will come, active component cos will come. We have studied diploma, but some CSE student and all the things it is difficult for them. Okay, so BC equal to B to C equal to I naught sine of this 90 minus alpha minus delta we have written. That is called BC here. That is called BC we are going to consider here. So sine theta, sorry, sine 90 minus theta we can write it as cos theta. Sine 90 minus theta, yes? Yes or no?
Yes, sir.
So that one only we have written. This minus we are going to consider as delta plus alpha we are going to consider, that is a theta here, no? So sine 90 minus delta minus alpha we are going to convert it into cos delta plus alpha here. So I naught cos delta plus I naught here. That is called BC we have identified. Next our term is AB we have to identify here. This is AB here. AB is I naught into cos of sine 90 minus delta minus alpha here. So sine 90 minus theta is nothing but cos 90 minus theta equal to sine theta we are going to consider. So again I naught sine delta plus cos theta we have identified. So up to here we have this derivations. We have to start. It is a starting point. I am telling that one. We have to write what you mean by OA, what you mean by AC, what you mean by BC, what you mean by AB. We have to written here. We have written here. Now actual derivation will start here. According to the impedance triangle, whatever the impedance triangle we are going to consider. Suppose you consider voltage triangle only. If it is impedance triangle or voltage triangle here, no, that is V square equal to VR square minus Vx square, we are going to call that one like that, or Z square equal to R square plus X square here, like that we are going to consider here. So like that we are going to consider, that is OC square here now. This one from here to here we are considering OC square equal to OA plus OB. The direct we can consider that one. Just a minute. You just imagine here now. I will start here. From here to here, we have to write the equation here. This one OC square equal to we have to start from this one OA plus AB plus BC square here. So OC square equal to OB square we have to write actually. Actually formula is OC square equal to OB square plus BC square here. OB square plus BC square equal to. This is O to B. It has split it into two parts here, no? Yes or no? OB equal to OA plus AB we can write.
Yes, sir.
So that one only they have written OA plus AB whole square plus BC square we have written. Now what you do? Up to here only important. इसके बाद कुछ नहीं रहते. Value substitute करो, calculation करो, ऐसे ही रहते. Okay. So now what we have to do? Substitute all the values whatever we have defined previously. To substitute. What do you mean by OA? OA is nothing but what? NIS here. No, NIS I have substituted. AB is nothing but what? Here the AB is there. That is I naught sine delta. I naught sine delta. You substitute here. I naught sine delta. And this whole square you write down. This is whole square. Plus you write plus symbol we have written here. No. BC square is there. What do you mean by BC? BC is equal to I naught cos delta plus alpha whole square equal to. Now this is very difficult part here. OA plus AB is there. OA is NIS plus AB is nothing but I naught sine delta plus theta here now. That is called A plus B whole square formula. Again it came here now. A plus B whole square. What is the equation for A plus B whole square? A square
Plus 2AB.
Plus 2AB
B square.
Plus B square over there. Plus B square here. So like that we have to use here now. So A is nothing but NIS, B is nothing but this complete term we are going to consider. N square IS square plus B square we are writing here now. I naught square sine square delta plus alpha plus 2NIS I naught sine delta plus alpha plus I naught this one whole square you karo. I naught square cos square delta plus square. So this is we have derived here now. So now from this one you consider here I naught square sine square alpha plus delta is there. Here I naught square cos square delta plus alpha is there. From this two you take I naught square outside लिए तो क्या हो जाएगा? Sin square plus theta plus cos square theta हो जाएगा. This is considered as theta. Yes.
Yes, sir.
So that is sin square theta plus cos square theta equal to what? One only.
Yes.
So that is called I naught square. So we have kept here now these two terms. By removing these two terms, we have kept I naught here now, I naught square, n square is square as it is we have kept. This is 2 ns I naught sine delta plus theta alpha as it is we have kept here. Next, that is called, what do you mean by OC here now? O to C, what is the value?
IP.
IP here now. So IP square equal to these all the things we have derived here. IP square we have derived here. Now this term IP we have to identify. IP equal to square root of n square I square plus 2 ns I naught sine delta plus alpha plus I naught square. is square root use कर सकते direct it whole square whole to the root 1 by 2 we can to the power of 1 by 2 we can write that. This is square root also. Okay. Now we know the transformation ratio formula that is called for CT here, that is called current, primary current to the secondary current we have considered. So transformation ratio, that is R equal to primary current to the secondary current here. So the primary current whatever we have derived, this one we have to substitute here, and secondary current you keep this one as IS as it is here. So here we have written n square IS. These all the things, same thing we have written here. Now what will happen? So here I naught and NIS we have to consider. By considering this one here, there is I naught is and NIS is negligibly small as compared to the I naught. Negligibly small as compared to the I naught value. On that condition, what we are going to consider, we are going to negligible this part, negligible, and here in this place of I naught square we are going to use the reactive component value we are going to use here, that is sine square delta plus alpha here. So by using this one, what will happen, I will consider rearranging the equation. You can write this much sentence if you are unable to remember. On that condition, rearranging the equation, we can write the transformation ratio R equal to n square I square 2 ns I naught sine delta plus alpha. So this one we can make as negligibly small here now. So we can remove the part. I naught square sine square delta plus alpha, that is whole to the root of, sorry, to the power of 1 by 2. To the power of 1 by 2 is nothing but square root it is going to indicate. Now consider here now. Here n square is there. Square root of n square, what is the value?
N.
N. That one we have written. IS square is there. Square root of IS square?
IS.
IS. Plus. I naught square is there. I square root of I naught square?
I naught.
Sine square delta plus alpha is there. Square root of that one?
Sine square delta.
Sine square theta, square root of sine square theta is equal to sine theta only, na?
Yes.
So sine
Yes.
delta plus alpha we have written. So IS we have written as it is here now. Now you split this term here now. You NIS divided by IS. So IS will get cancelled. Only term will left here now. N here now. Next I naught by IS sine delta plus alpha. This is the transformation ratio equation of the current transformer. This one is the transformation equation for the current transformer. So still the derivation it is over for only transformation ratio, but some phase angle error is also there here now. The phase angle derivation we have to consider. So actually by seeing this triangle only, by considering this triangle only, tan theta equation we can write. Tan theta equal to BC divided by OB we are going to consider. This BC is nothing but what? Opposite. Yes, AB is adjacent. Opposite by adjacent, that will give the tan theta formula. Yes or no? Opposite by adjacent only, na? Tan theta equal to? So opposite by adjacent. So BC equal to BC we are going to consider. OB equal to again NIS and that AB term we are going to add here now. So BC equal to I naught cos delta plus alpha. OA equal to NIS. AB equal to I naught sine delta plus alpha. So substituting, considering this one here now, as theta is very small, we can write directly tan theta equal to this as it is, or if this same term we can write I naught cos delta, that is called in radian we can consider here. We can write in radian here now. So but now here what we have to do, as I naught is very small as compared to NS here now, NIS, on that condition we can neglect this term here now. By neglecting this term here now, on that condition theta is directly proportional to I naught cos delta plus alpha. Only term left here is nothing but NIS will be left here. So NIS we can write. So from this, again, they have not stopped here only. They have considered cos A plus B formula. Cos A plus B formula मालूम है क्या? Yes. Anyone?
No.
So by applying cos A plus formula, A plus B formula, that cos A cos B minus sin A sin B. Yes or no? So applying that one here, cos A cos delta cos alpha minus I naught sin delta sin alpha they have used here now. So I naught and cos delta, that is called maximum value here now. From this one, from this phasor diagram again here now we have to go for the phasor diagram. Where kahan gaye ho? Here, see here, this is I naught is there here now. So this Im is nothing but what? This I naught and cos alpha we can consider. Yes or no? Cos alpha. This one I naught sin alpha here now. That one we can replace Im and IE, we have to replace that one here. Im equal to, we can write cos I naught cos alpha equal to Im. I naught sin alpha equal to IE we can write here now. That one only we have written here. See here. So by considering Im cos delta here now, this I naught and cos alpha, that one we have considered as Im here. This term I naught हमने नहीं लिखा इधर and cos alpha नहीं लिखा, ये दोनों consider करके हमने Im लिखा है. Cos delta we have kept as it is here now. Minus sin minus, again I naught sin alpha equal to IE we have considered from the phasor diagram, that is called IE here. We have written here. That is called, this is phase angle we are going to call here. So this is radian is there, 180 by 5. By doing this one we will get the phase angle, sorry, degree in degree we are going to get here. So this completes the phasor diagram and the transformation ratio and phase angle derivation of the current transformer here. Current transformer. Listen carefully. If you are, suppose you want to give the offline exam, means it is very difficult. You have to practice it 2 to 3 times. You people are lucky now, it is online exams are there. So you can only, the questions may come, the formula may come, they can ask you people about that one. Is it clear? Yes. So some errors are there actually, phase angle error and all the things we are going to consider. So the percentage ratio of error, that is called ratio error, we are going to consider here. No, that is called, is defined as the ratio of difference between nominal ratio and actual ratio to the actual ratio here. Nominal ratio we are going to consider as Kn here. No, Kn minus actual ratio is R divided by R here. Nominal ratio minus actual ratio divided by actual ratio, that is called percentage ratio error we are going to consider. So Kn minus R divided by R into 100. Already we have calculated this R formula. You can substitute here now. This R formula we have calculated, you can substitute, you can extend that equation, otherwise you can keep directly this one here now. The phase angle error is nothing but whatever we have calculated the theta, that is the phase angle error or phase angle equation we are going to call here now. That one we can write, that is 180 by 5 Im cos delta minus IE sin delta NIS. So it completes the current transformer. So tomorrow we'll discuss about potential transformers. We are going to discuss in the next class. Okay. So the absent number directly I will call. You can check it. Roll number 1, roll number 11, roll number 15, 17, 19, 24, 25, 27, 31, 32, 34, 36, 37, 38. Anybody is there? You can give your present. Is it clear? The derivation you practice it already. I have uploaded this one in the, where it is, the drive it is there. This PPT is already there. You can check it and you can practice it. Is it clear?
Yes, sir.
Okay. We will stop here only and we will continue in the next class.